Hello, welcome back. And this is actually not any new lecture. I thought of introducing you to a very interesting tool. I mean, in fact, not very powerful, but a good educational tool to understand the concepts of sensor arrays or transducer arrays. Thanks to Hari Krishnan actually for pointing this out. I knew that such a tool exists, but he has actually tried this out, and it seems to be quite intuitive to learn so many things using this tool. Okay, so what is this tool I'm talking about? So all of you need to install, of course, Matlab here, and I think it's better to go for the latest edition of Matlab so that you are up to date with any toolboxes option. And being an academic institute, we do have most of the licenses available, so you need to actually how to use this particular tool. You need to have the sensor array analyzer. Okay, so this is coming under signal processing and communication, but I think we need to install phased array toolbox. So how to know which all toolboxes are there in your Matlab window? Just go here and type version, so it will list down all the toolboxes that you have currently installed. And if you don't see this toolbox, I suggest you to install this. And this particular app, once you install this toolbox, this particular app should come here. Okay, in the apps, so home, apps, if you expand this in signal processing and communication, you do have a sensor array analyzer. So if you click on that, the window will come, and you can already see what I was talking about. So let it open. Okay, so it's already open for me, and here actually let me make it full screen for you. So you can see over here the options are uniform linear array, and then of course the uniform rectangular array, uniform circular array, hexagonal array, and so many options are there. Unfortunately, the random, I've not actually tried it out. I'm not very sure, but it seems like random is not possible. But let's stick to this uniform linear array because that's what we have been doing quite a lot. And you can change the number of elements here. Currently it's 4 of them, and then spacing is important for us, so we'll come to that later. Then the axis is typically Y, so you can change it according to your convenience. So you can, let's say I want, like in ultrasound, let it be X, and you apply, so it will come to X direction for the array. So you can see over here, and then Y will be our transmit direction. And then you can even do some sort of windowing if you want, the tapering, the apodization, basically signal shaping you could say. And element spacing, the option is in meter and lambda, so let me put to lambda because that's much easier for us to play with. And then on the top you do have, I think subarray option is there, but I didn't try it out, so let's not you can explore it of course. And then here antennas, microphones, and sonar transducers are available, so you can choose any of them. Isotropic means it is going all directions, it's not going in one direction. You can choose sort of custom also if you want. Just let's say you want to have the backing layer effect so that back propagation is not there, you can use that. Hydrophones also, if you are going to work on sonar, hydrophone, I mean ultrasound, you can use the hydrophone. But let's stick to this because it doesn't matter much. But one major drawback I could see is actually there is no control on the shape of the sources or the extent of the transducers or the antennas. It will be all are point sources. So that's another issue because we don't have control on the let's say I want it to be rectangle, I want to be circular, cylindrical, or spherical. That control is not there unfortunately, but that's okay because you will be able to understand some concepts pretty clearly from here. And then you can enable the 3D and the 2D patterns, so separate window will come, and you can see over here with the given 4-dimensional array you will be able to rotate and see. So this is actually isotropic, so you can see that it is essentially going in one direction in the Y direction, and Z direction is really uniform. You can actually see that. I think this is let's come back to this after some point. Okay, and then okay, then let's enable the 2D pattern also, and we are only interested in the azimuthal pattern. That's what this is for the original one. I didn't apply anything, so something here, we'll come back to this after it makes some meaning to us. Okay, so that's it. Then grating lobe diagram also let me enable so that everything is here. Okay, so this actually shows where the grating lobe comes. So free area is this, and then grating lobe area. These are going to be the grating lobe area in terms of you can say the angle. And yeah, I think that's it. Okay, I think that's it. So now let's start to play with this. So 4, so the current lambda spacing is 0.5, and then propagation speed you can actually change. So basically frequency is 3 raised to 8, so this will be like 1 lambda sort of, because frequency, yeah, it's 1 lambda, so right, 1 meter spacing actually. But let's actually play with this guy. Okay, so I'm going to change the element spacing to something very small. So let's say this. Okay, now let me just see the patterns. So you can see that side lobes are gone, right? So basically, or grating lobes rather, not side lobes, grating lobes are sort of gone, and then you can see it solidly. So the grating lobes are out of our normal window, so it's completely gone. You can also see here it's completely gone. Now 0.5 you already seen it, but let's come back to that. 0.5 lambda, so let's come back to that. So you can see the grating lobe started coming, and I think this will give you a picture. So you can see the grating lobes are here. Okay, and in fact the side lobes are not very prominent because we don't have a structure, right? It's just point source, so it doesn't have that effect of side lobes. Okay, so now let me actually increase it. Let's say 1 lambda. Let me see the 3D pattern. I think you already seen that actually, 3D pattern. So let's stick to this and maybe make it 1 lambda. Okay, so 1 lambda, let's see how it goes. Yeah, you can immediately see it. So the main lobe is there, but then the grating lobes have become very serious now, right? And if I increase it, let's say 1.5 lambda, so it really is significantly distorted, as you can see over here. And then yeah, there is no free area literally, right? And this is the thing. So you can actually try to play with it. This is a very quick video. I just wanted to update this interesting tool. So in case you are interested, please go ahead and see this. You can do a lot of things actually. The time also you can consider here. For example, there is an option in the analyzer window. uh, we could actually give the frequency and then see the change. Let me just quickly see if that works out. So azimuthal pattern, let me go back to 0.5 lambda, or let's say 1 lambda, so that some grating lobe is there. Okay, so let's actually make it 6. Yeah, I mean there is not much of a change, because this is changing with respect to lambda, right? So it changes accordingly, so we won't see that much of a change. Okay, you can see back baffled. If I enable this, the back side will be gone completely, that we can see. Yeah, there's no transmission in this side. It is just this particular thing, basically 180-degree only. So you can even see here 3D pattern. So it just shows that only in the y direction it propagates, not in the back direction. And you can even see the grating lobes, the impact of grating lobes in a very uh, pretty way, right? So this is relatively low, but this is significant grating lobe here. So if I put 0.5, so you can see some area is actually free, and that is what it is. So you can see it here. So that's all. Okay, so that's the major thing I just wanted to update you. Very quick video, 10 minutes sort of video, so that you can try out this and do a lot of, in fact all of some characteristics are all reflected here, which will be useful for you. You can play with, in fact, the hydrophones, where it will give some more options. So you can see it here. So okay, so that's it from my side for this short video. I hope you enjoy this. Thank you.